Today we're going to be having a look at how to create a residual plot. And the first thing that you should be asking is, what is a residual plot? Great question. So, a residual plot is a graph that shows us whether data is linear or non-linear. Okay? So this is the goal of the residual plot, is it tells us the form for sure, okay? So in all of the previous ones we've been looking at, form has always been like, oh yeah, like does that data look linear or does it look non-linear? And there's been a bit of hand waving as to decide whether we think something is linear or whether we think something looks not so linear. Okay? And so the purpose of a residual plot is to give us a little bit more definition as to whether the form is linear or whether the form of the graph is nonlinear. Alrighty, so in order to actually do the residual plot, it's a four-step process. So you need to calculate your least squares equation. You can just use your calculator for that. You need to calculate yp, then you're going to calculate your residuals, which is ya minus yp, and then you are going to plot the graph itself. So it's a four-step process, and we're going to take it step by step. So let's get some data. So here's our data. You got x and y, and you can see there that as x is increasing, y is also increasing. So there definitely seems to be some kind of positive association between these two variables. And the question is it a linear or is it non-linear? So let's calculate the least squares equation for this. And the way we do that is we're just going to use our calculator, y equals a plus bx. And we're just going to use our calculator stat mode and we're going to figure it out. So I'm going to do that now. After doing regression, I got that a is equal to negative 10.08 and b is equal to 1.40 to 2 decimal places. So my line of best fit, part 1, is y is equal to negative 10.08 plus 1.40x. Alrighty, so now I can jump on to step 2, which is to calculate yp. So let's just go through what the difference between ya is and yp is. So ya means the actual data. So the data we've already got in the table, we call that ya because it's the actual y. Yp, on the other hand, is based off this least squares equation graph. So to calculate yp, we're going to sub x into here to figure it out, the predicted y's. Okay? So that's y actual, and this is y predicted. So since I've got 7 x variables, x values, I need to sub in 7 times into this formula. So I'll show you the first one. So when x equals 10, we get y is equal to minus 10.08 plus 1.40 times 10, which is equal to 3.92. Okay? So where am I going to put that piece of information? Well, I'm actually going to add to my table. And in fact, I'm going to have 2 extra rows in this table. So I'm just going to get ourselves prepared. So the next row in the table is going to be the y predicted. Okay, so this is going to be yp. And you can see that my first yp for when x equals 10 is 3.92. Now I'm going to take the next value of x. And the next value of x is x equals 15. And I'm going to sub that in to the equation. And in this case, this is a great chance to use the editing rather than rewriting your equation. So if you use the left and right arrows on your keyboard, on your calculator, you should be able to go back and actually edit the equation rather than retyping it every single time. It's going to save you a lot of time. So 10.92. And we're just going to repeat that for every single value until I've done it for x equals 10, 15, 18, 25, 28, 30, and 32. So I'm going to go through and do that quickly now. Alrighty, so I've just substituted 7 times into the one equation to get that row in the table. So that was 7 substitutions that it took to do that. I'm just going to put that one back in black. Oh, I had that on pause. Alrighty, so I've finished up that bottom row, and now I'm going on to calculating my residuals. And so you can see here that I've got my first residual to calculate is the actual value, so that's YA, 9 for the first column, right? For the x equals 10, we got 9, minus what the equation predicted, which was 3.92. That's what I worked out over here. So I'm just going to work out the difference between those two, and that's going to tell me whether the prediction was too high or too small. And in this case, the prediction was 0.58 too small, okay? Because it was smaller than the actual. So I can put that 5.08, and I can calculate the next residual, YA minus YP. Let's do it for the second column, is going to be 10 minus 10.92. And you can see in this case that it's slightly bigger than it should have been, and so we're going to get a negative answer here. So negative 0.92, so it was slightly too big. And once again, I'm going to repeat this calculation. This is just a bulk calculation, and it does take a little bit of time. So I'm going to pause and do that now. Alrighty, so I've now calculated all of the residuals, and that just leaves us for the last step, which is to plot. And in particular, when we do the plot, we're only going to be plotting the x and the residuals. So that looks a little bit funny. So let's go clear out a bit of space, and then I'll put this onto a graph. So I've done all my calculations, and now I'm going to number 4, plot. So step 1, set up your axes. Now these plots are slightly different. You notice that I've kind of drawn a sideways T here. That's purposeful. This is not an accident. Residual plots always look a little bit strange. You're going to have x coming along here on the x-axis per normal, but our residuals is going to be running up this vertical. Okay, the x is the easier part, so let's start there. So I need to go from 10 up to 32. So let's just go up and let's try 5. So 5, 10, 15, 20, 25, 30, 35. Okay, so that's going to work fine. So 10, 20, 30, and that's going to fit all of my x numbers from the table. So that's all of these numbers up the top. Now I'm going to do the same thing, but for the residuals. So the largest residual I have, the most positive, is 10. So maybe we'll go up 5, 10. And then on the other side, we're going to have negatives. So we're going to have negative 5, negative 10. Okie dokie. And now we're just going to plot. So the first point is 10, 5.0. So 10, I don't think it was meant to be 5.0. I'm going to recalculate it now. 5.08, so pretty much 5. So 10, 5 is the first point. 15 is negative 0.92, so very, very little bit below the axes. 18 is going to be negative 2, so that's about here. 25 is the next one, and it's negative 6.92. And we've got 28 is negative 5. $30 is going to be negative 0.82. And at 32, we're going to get 10.28. Alrighty, so this is probably a bit too high. So something like that. And you can almost see sort of a smiley shape here happening. Now, the residual plot's an interesting plot because it almost doesn't make sense. If the plot is random, then that tells us that the data is linear, okay? So remember, what was the goal of all of this? Residual plot is a graph that shows us where the data is linear or nonlinear. So if the plot is random, then the data is linear, which means if the plot has a pattern, then the data is non-linear, okay? So a bit of a strange definition for the residual plot, but in this case, I would say that there is a slight pattern, right? You can kind of see a smiley face showing up here. It's not like it's random. It's kind of gone down and then it's kind of come back up. So I would say in this particular case that the residual has a pattern. So that tells us that since it has a pattern, it is nonlinear. So the data is nonlinear. And that is how you produce and use a residual plot. I'll see you in the next one. Goodbye.